In this video, I'll be discussing a problem involving constant term and binomial expansion. If the third term of the binomial expansion of parentheses cube root of x minus 1 over x to the power of n is a constant term, then n equals. Before we actually get into the problem, let's first see what this new symbol means. This weird symbol will mean that n is a positive natural number. Okay, and now let's just discuss some of the terms here. First of all, let's take a plus b squared as example. This will equal to a squared plus 2ab plus b squared. This will be the binomial expansion of a plus b squared. And the third term will be b squared. Same applies for a plus b cubed. This will equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. And then the third term will be 3ab squared. And then a plus b to the fourth power will equal to a to the fourth power plus 4 times a cubed b plus 6 a squared b squared plus 4 ab cubed plus b cubed. And similarly, the third term will be 6a squared b squared. Okay, now that we know what binomial expansion and third term is, let's get into the actual problem. Well, note that in each of these binomial expansions, each term will actually be a to some power times b to some power. Like a squared equals to a to the power of 2 times b to the power of 0. 2ab will equal to 2 times a to the power of 1 times b to the power of 1. So now that we know what the pattern is, let's get into the actual problem. Well, we know that from this problem, cube root of x to some power multiplied by 1 over x to some power, this will equal to a constant. Now, we have to find what each specific power is. Well, let's first list some examples. 3, 1, 6, 2, 9, 3. I will explain what each of these numbers respond to. 3, 6, 9 are each powers of cube root of x. So, the cube root of x to the power of 3 equals to x. The cube root of x to the power of 6 equals to x squared. The cube root of x to the power of 9 is x cubed. 1 over x to the power of 1 equals to 1 over x. 1 over x to the power of 2 is 1 over x squared. 1 over x to the power of 3 is 1 over x cubed. Note that 3, 1 is a pair, 6, 2 is a pair, 9, 3 is a pair. And each of these pairs have a product of 1. And 1 is a constant. However, this problem would be too easy if there was infinite solutions. The problem specifically said that the third term of the binomial expansion is the constant term. So, only 6, 2 works. Here is why. If it was 3, 1, this would actually be a plus b. Let's just take an example. A plus b to the fourth power. And then we can already get a plus b to the fourth power. And here we can get that this will be some power of a cubed b. Like I already wrote here, the full expansion, a cubed b. And then for 9 and 3, it will be a plus b to the power of 12. It will be something a9b cubed. for the a plus b to the power 4, you can get that 4a cubed b is obviously the second term. And for a plus b to the power 12, a to the power 9 times b cubed will be the fourth term. Because the first one will be a12b1. No, the first term will be a12b0. The second term will be a11b1. The third term will be a10b2. And then the fourth term will be a9b3. So the only option will be 6, 2, which is a plus b to the power of 8 will equal to dot 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 a6 b2. I'm not going to write a specific expansion here, but then note that the powers of a and b are going to be respectively a to the power of 8 times b to the power of 0, and then a to the power of 7 times b to the power of 1, and then the third term will be a to the power of 6 times b to the power of 2. So we get that n will equal to 8 when the third term of the binomial expansion is going to be the constant. So the answer to this problem is going to be 8.